Okay, so we're going to solve this integral, this definite integral, and just looking at it, the method that you would use would be partial fractions, which will break this down, break it down into partial fractions, and then the answer will be a series of logarithms. Alright, so what we do is we work on the integrand and we decompose this. So we'll write x minus 2 on x minus 1, x plus 2. Always equal. I'm writing three lines there. This has got to be always equal for all values of x. So I can actually write this as a bit technical, but anyway, we'll break this down into a over x minus 1 plus b over x plus 2. Okay, we've got to solve for a and b. Once we've got that, these are easy to integrate. Alright, so multiply both sides by the denominator. You get x minus 2 is always equal to a over x plus 2 plus b over x minus 1. Okay, now there's two ways to do this. Probably the easiest way is just to sub in values which kill off some of these terms, so you put negative 2 in here and that'll get rid of that term, or you put 1 in. The other way, just to mention, because this could make it a bit easier sometimes, is that because this has to always equal that, the coefficient of x is 1 on the left hand side, the coefficient of x has to be 1 on the right hand side, so a plus b has to equal 1, and 2a minus b has to equal minus 2, so you could solve it that way, but it's normally easier just to sub in. So let's let x equal minus 2, and that implies that minus 4 is equal to, first term's gone, minus 3b, which means that b equals 4/3. Now I'll just use my other method and say that, well, a plus b must be 1. So if that's 4/3, that's got to be minus 1. Sorry, a has to be minus 1/3, just to cut through a bit of work. Otherwise I've got to set 1 and up here you get the same answer. Okay, so therefore integral becomes, can I just move that up? Integral becomes, integral is equal to, I should probably have written 2 to 3. Now what have we got? Let's just look at this for a second. Minus 1/3, put a bracket around that, over x minus 1 plus 4/3, yep, over x plus 2. This is a logical spot to stop in the question and check. You would not want to load the wrong coefficients in above them, so that looks right. Okay, alright, just one bit of cleaning up we'll just take 1/3 out the front of the integral 2 to 3, just to make this a bit easier. Minus 1 on the top, x minus 1, I'll put a bracket around there just to be a little bit pedantic, but anyway, 4 over x plus 2, okay, dx, and then put a bracket around that, so that's right. Now that's now in the form we want, so what we'll do is we'll just write the integral down now. I'll write this one first. Well, that's 4 by, there's 1/3 outside of 4 by log to the base e. I could have written ln, but write log to the base e, x plus 2 minus log to the base e again, x minus 1, put a bracket there, and then just evaluate. We're going to evaluate that at 2 and 3. Just to tidy this up, perhaps I'll write this as one logarithm, 1/3. Now the 4 can come in and make this x plus 2 to the 4, so I can do a bit of logarithm algebra here. It's a log of x plus 2 to the 4 over x minus 1. It's over because there's a minus there, so that's equivalent to a division for logs. So is that clear? 2 and 3. Alright, okay, so we've got to evaluate this. Alright, okay, 1/3 log e. Put the 3 in now. It's 5 to the 4 on 2, log 5 to the 4 divided by 2. And make a bracket there, minus. Now put the 3 in, log put the 2 in. 2 plus 2 is 4 to the 4. There's a minus 1 there. 2 minus 1 is 1, so that's okay. So it's just that. And we can, if we want to do, we can combine it further and write the answer as log 5 to the 4 on 2 by 4 to the 4. And that's roughly equal to 0.66. And that's the correct answer. I've checked that with a numerical integration tool, and that's correct. So that's the answer.